Normally, when you see a quadratic that looks like this, you would find out what the common factors are, and then you would be able to represent it in two set of brackets that you can then solve for x. Because this can't be done for this formula, you would then use the quadratic formula. However, this type of question is usually found in a non-calculator paper, and for some reason, you can't use a calculator in that paper. So the quadratic formula is not going to be useful. So they'll ask you to complete the square. Resist the urge to factorize this and leave this minus 1 alone. We're going to look at the first two terms. Everything that is in the b position, so ax squared plus bx plus c, this b position, you half it. So it'll be 1. And then you will put x beneath. So let's do x plus, and then this half of this is 1. And let's square it. So this is the same as this. And if we expand that, you're going to get x squared plus 2x plus 1. So this is exactly the same as this, but we have an additional 1. So if we write x plus 1 all squared minus 1, this is exactly the same as this. And then remember, we have a minus 1 here. So now, let's sort this out. So obviously minus 1 is minus 2. So you're going to have x plus 1 all squared minus 2 equals 0. We can now move this 2 to the other side. So let's do that. We're going to have x plus 1 all squared would equal 2. How do we get rid of the squared on this side? Is by square rooting it. So let's square root both sides, this side and this side. So that would then become x plus 1, and this would be plus or minus square root of 2. That means that we'll have two solutions for x, one where the surd is positive and one where the surd is negative. So both the solutions, once we've minus 1 from both sides, would be x equals plus minus square root 2 minus 1. So when x equals root 2 minus 1, this would be the exact same as 0.41. Or when x equals minus root 2 minus 1, this is the same as minus 2.41. In an exam, leaving these two solutions will be enough. A non-calculator paper is very unlikely to ask you to draw the graph. However, me representing it as numbers helps you understand what we've actually calculated. So we have some sort of quadratic where the x terms, the graph crosses the x-axis at 0.41 and minus 2.41. Although this isn't enough information for us to draw the entire graph, because we'll need to find out what the turning point and the y-axis is, this is roughly what it will look like. And that is what we are doing by completing this square. Let's go through another problem. So, same as last time. Let's ignore the minus 5 and let's take whatever this number is and half it. So x plus 7 squared minus 5 equals 0. However, x plus 7 squared is going to produce something that we don't want. So let's expand that. That's going to be x squared plus 14x plus 49. We want to get rid of this 49, so x plus 7 all squared minus 49, that is now the same as that, minus 5 will equal 0. We can now sort this out. So that's obviously going to be minus 54. So we'll have x plus 7 all squared minus 54 is equal to 0. And we can now move the 54 to the other side. x plus 7 all squared will equal 54. We square root both sides. Eliminating this squared symbol here, we'll have x plus 7 equals plus or minus root 54. If we now subtract 7 from both sides, you will get x equals root 54 minus 7 and x equals minus root 54 minus 7. This is sufficient for you to leave as the answer, but just so that you know what this looks like as a number, this is 0.35, and minus root 54 minus 7 is going to be minus 14.35. We've successfully completed the square.